Good morning, Algebra. We are going to recap exponential functions real quick, at least the parts of the exponential functions that move things around. And then today is about domain and range. Domain and range is going to be very similar to quadratic. So if you understood the domain and range for quadratic functions, this one will be a breeze. So real quick, let's start with the function for our exponents, or our exponential functions. All right. We have our a, we have our b, we have our c, just like we've had a, b, and c in quadratics and other things before. And each thing has a specific movement that it does. So whether or not a is positive or negative, you remember doing this with quadratics. Whenever a is positive or negative, it has a certain movement to it. Whenever we had quadratics, if a was positive, it was up like a cup. And if a was negative, it was down like a frown. Well, it's very similar this time. When a is positive, it will either be kind of like this. That's ugly. It'll be kind of like this or like this. Okay. Either one of those. It'll be an exponential growth or exponential decay, but it'll go up forever. All right. And then if it's negative, it'll be reflected across the y-axis, so it'll go down forever. All right. Remember, if a is bigger than 1, if a is greater than 1, it's going to be a stretch. It's going to increase really, really, really quickly, right? And if a is less than 1, it's going to be kind of a compression. It's going to slowly increase over time. All right, so this is, if it's greater than 1, it's kind of real steep. And if it's less than 1, it's more slopey. All right. Then we covered B. We covered B in the notes. When B is greater than 1, we have exponential growth, which when x increases, y increases, right? And if we have B is less than 1, we have exponential decay, which is more like when x increases, y decreases. Okay? So we have those two kind of movements right there. And then when we have plus c, we're shifting up. And when we have minus c, we're shifting down. You remember that controls our asymptote. So our asymptote is raised or our asymptote is lowered. Okay. And then the parent function will just have an asymptote of 0. Okay. So I know that kind of looks like chicken scratch maybe, but we've covered this type of thing in class before. If you don't remember, check your notes over quadratic functions. Each thing has a movement, right? So positive up front means it's going up toward the sky. Negative up front means it's going down as far as it can go, right? So it goes down forever in this situation, and it goes up forever in this situation. The asymptotes would occur somewhere around here for each of those, okay? If A is positive, or if A is greater than 1, it's very, very steep. If A is less than 1, it's very, very shallow or very, very slopey. B controls exponential growth versus exponential decay if it's less than 1. And then C is just shifting the asymptote up or shifting the asymptote down. All right. I'm going to hit pause real quick and get everything squared away. Please make sure you have your notes ready to roll. I'm going to hit pause later on and have you fill out some things ahead of time. So go ahead and get all that set up. All right. The first thing it wants to do is discuss domain and range. I would like to discuss this a little bit later as well. But first, domain, we have our theoretical world and we have our real world, as we always do. You remember, infinity rarely exists in the real world. So in theoretical world, you remember theoretical world is just equations, graphs, things like that. Real world is, things that, word problems that include someone's name, Ricky, Bobby, Tommy, Susie, Timmy, something like that. And then a real world item. So like money, population, things of that nature that we're going to discuss whenever we're covering exponential functions. So for the beginning, though, our domain is going to be all real numbers. So our domain will be all real numbers because the one that you're looking at right now, the first slide after the warm-up right there, is is a theoretical world exponential function. It's going to go to the left forever and ever and ever, right? It hit that asymptote, and it's going to continue going to the left forever and ever and ever. And then it's going to go up forever and ever and ever, but it can't go straight up. It has to keep going away as well. So we know that it's going up and to the right forever and ever and ever. So we know that it's going to be all real numbers. And then range is very specific. Range really just depends on A and C, okay? B doesn't really, the range, whether or not it's exponential growth or exponential decay, it doesn't matter. All we're looking at is if it's facing up, if the equation is positive, or if it's facing down, if the equation is negative. And then we're looking at where the asymptote is. So when A is positive, y is greater than the asymptote. And when A is negative, y is less than the asymptote. And remember, the asymptote is just C, so the value of C. So y is greater than when A is positive, the value of C. And when A is negative, y is less than the value of C. All right, so let's look at number 1 together. Number 1 has the equation 5 to the power of x. First things first, you need to make a table. Always do the meat and potatoes of the graph, which is -2, -1, 0, 1, and 2. And we see that it is going to be exponential growth. We look at our numbers here, and we get very small very quickly. We're approaching 0 because it's going 0.04. That's getting very small, right? And then it's also increasing very quickly. It goes from 1 to 5 to 25, right? Off the chart already by the number 2. So our graph will look something like this. It is exponential growth. It is a positive shaped graph. Our A is positive, right? Our A is positive. It's a positive 1. Remember, this is our B. The one that's attached to the exponent is the B. So the number up front is positive 1. And then our C is 0. So we know because A is positive and C is 0, we know that our range will be y is greater than 0. And because it's a theoretical problem, because there's no real world word in this, we know that the domain is all real numbers. It's going to continue going to the left forever, and it's going to continue going up and to the right forever. All right. Number 2. Number 2 is a little bit different, not a whole lot though. The equation is f of x is equal to 3/2 to the power of x minus 7. The only thing that really changed here is our c. We now have a c value. A is still a positive 1. So make a table. I made a large table for this one because it's a very nice slopey graph, right? That number's not very big. It's just 1.5, and then the number out here is 1. So it's not changing very much over time. It is changing, but not very much over time. And it takes a little while for it to get pretty big. This is more realistic in real world problems. Most things don't just whop, out of control, just go straight north. So whenever we graph this, we see that it's a nice slopey equation. It's still positive in shape. It's still going all real numbers. We're going to the left forever. We're going up and to the right forever. You remember it has continued going that direction, both directions. So we know that our domain is going to be all real numbers. And just based on the equation, we have a positive A, a positive 1. So we know y will be greater than our c value, -7. So that is going to be our range. Y is greater than -7. It can't be equal to it. That's the asymptote. You can never be equal to the asymptote. So y is greater than -7. All right. Go ahead and hit pause and try to do number 3, 4, 5, 6, 7, and 8, just based on the information you know. All real numbers for our domain because they're all theoretical so far. We won't change that until we get into real world problems. And then just look at A to see if it's positive or negative. If it's positive, y is greater than. If it's negative, y is less than. And then I want you to look at the asymptote, the very last number, C. So y will be greater than or less than that number. So hit pause for me, and then I'll come back and talk to you in a second. Go ahead and finish 3 through 8. All right, when we are looking at number 3, it says 3 times 1/2 to the power of x. We know by the b being 1/2 that it's exponential decay. But like I said before, the b doesn't matter in this situation. We're just looking for the domain and range. We know the domain is going to be all real numbers, and we know the range will be y is greater than 0 because a is positive. It's a positive 3, so y is greater than. And our c is 0, the number on the very back that you add or subtract. That is 0, so we know it's y is greater than 0. If you look at number 4, we have a positive a again. We have a negative 2 for our c, so it will be y is greater than, because a is positive, negative 2, because that's our c. And then the domain, of course, will be all real numbers. Number 5, we finally have a negative a, so it will be y is less than for our range. Okay, do you see that? We have a negative 2 up front, so that's an a, which is a negative value. So our range will be y is less than. Less than what? It's our c. So y is less than positive 1. And then our domain for that one will, of course, be all real numbers. And I'll put a key up at the very end for you to check. But we're just going to continue to walk through these. Number 6, what is the range of the function y equals negative 10 times 1/10 to the power of x? It says, what is the range? So we're looking at a, and we're looking at c. Our a is negative, so it will be y is less than. And our c is non-existent, so we know that that answer is 0. So we know it's y is less than 0, or b. Number 7. Number 7 says, what is the domain of the function? And we don't even need to pay attention to the rest of that information. It's not a real-world problem. It's very much a theoretical problem because there's no word in there that says this is real. There's no name of anybody. There's no nothing. So we know it's a theoretical problem. We don't have to do a lick of math. The answer is all real numbers. Number 8, this is the last little problem here. How would the range of the function y is equal to 600 times 3 to the power of x be affected if the function were changed to y is 800 times 3 to the power of x? Well, it says what happens to the range? So what two things are we looking at? We're looking at a and we're looking at c. And really, we're looking at a to see if it's positive or negative. Okay? If it's positive, we know y is greater than. If it's negative, we know y is less than. So in both of those, we have a positive a, 600 and 800. So both of them will say y is greater than. And we know it's greater than c, which is the same on both of those as well. C is added or subtracted onto the back of the problem. So we know that the range for both of those will be y is greater than 0. So the answer is B. It would not be affected. Nothing changed that affects the range. Yes, the A changed, but it didn't change from a positive to a negative or from a negative to a positive. And the C didn't change at all, so there would be no change. Here's the key for the end of that, 3 through 8 for you. I hope that's readable. All right, you have a wonderful day. I will post a key to the work in just a little bit. I have 2 meetings today, one from 8 to 9 and one from 9 to 10. So it might take me a little longer than usual. All right, I will talk to you tomorrow.